Hi friends, we're going to do our Chapter 2 mid-chapter test review. Okay, let's get started. The first one, we're actually writing equations for these sentences. So we've got the sum of 3 times a and 4. When we talk about the sum of, we're adding two things together. What are those two things? 3a and 4. It is, we know that refers to equals, it is the same as 5 times a. Number 2, 1/4 of m minus 6 is equal to 2 times the sum of m and 9. So if we're talking about 1/4 of m minus 6, we can write it like this, and that's equal to 2 times the sum, 2 times open parentheses, m plus 9. I can see a potential problem with this because is it 1/4 m minus 6 or is it 1/4 m minus, let me do it here, m minus 6. So the question is, should we put it in parentheses? On your test, I will make it more clear than this. If I were to give you something broad like this and you were to put a parenthesis here, I wouldn't be terribly upset because I know that that it wasn't clear. I think it should read, if the parentheses belong there, personally I think it should read 1/4 the difference of m and x. Get me? All right. This next one, the product. Product means multiply, the answer you get when you multiply. The product of 5 and w is the same as w to the third power. So that's 5w is the same as w to the third power. This next one is going to require a little bit of space. Whenever we have an equation, just preempting, whenever we have an equation that we want to solve, we really like to have as few variables as possible. Here, we've got Drew with 50 red, green, and blue marbles. That's 50 marbles total. And so we've got, I'm going to do it along this margin, we've got red plus green plus blue is equal to 50, where those letters refer to the marbles of those colors. He has the number of marbles of those colors. He has 6 more red marbles than blue marbles, so that means red can be written in terms of B plus 6. And then it refers to he has 4 fewer green marbles than blue marbles, so then that means green can be written in terms of B minus 4. Now it's just a matter of substituting. Instead of having R and G in this equation up here, I would like to just have B, so I'm going to rewrite it. So this equation should be pretty simple to solve. Notice I underlined the replacement for red in red and the replacement for green in green. So now we're just going to join like terms. We've got 3 B's on this side. I've got a plus 6 and a minus 4, which gives me a positive 2. And that's all equal to 50. And then I'm going to solve by subtracting both sides by 2. 3b is equal to 48, and that means that b is equal to 16. So yes, this is good that you got an answer, but we need to make sure that we're answering the question. So it says write and solve an equation to determine how many blue marbles. Since b refers to blue, we have done that, 16 blue marbles. Okay, p plus 8 is equal to 13 here in number 5. So I'm going to subtract 8 from both sides. P is equal to a positive 5. I'll put my 5 right here and get started on the next problem. So this one's a little bit more difficult, but you guys should be comfortable with this. On this problem, negative 26 is equal to b minus 3. We're going to add 3 to both sides because remember our goal is to isolate our variable, which is b. When I add the opposite or the additive inverse, they go away on this side. Let me put my line down here. And I've got b is equal to negative 26 plus 3 is going to give me a negative 23, and that's my answer. And for number 7, what we need to do is consider what's happening to our variable t. It is being divided by 6, so we need to undo that division. We do that by multiplication. What you do to one side, you've got to do to the other. When I do that, I could get 6t over 6, but we're grown. We can do that. We can do some cross-canceling, and t is therefore equal to 18. I'm going to solve this problem like an algebra teacher, number 8, But I do want you to consider that when you're taking multiple choice tests like the ERBs or SATs one day, realize that if the answer choice is given, you can also plug in your answers, right? And see which one fits. That's also a strategy that you can use and you should keep in mind. I don't give multiple choice tests very often, so that's not a strategy we're going to employ. We're going to do the math. So here we have it. 3/5 A is equal to 1/4. Who's bothering A? 3/5 is bothering A. It is bothering by multiplying. We do something special when we're dealing with a fraction multiplied by a variable. We can just multiply by the reciprocal to finish off the job very quickly. So when I multiply 3/5 by 5/3, I get a lot of nice cross canceling and I get A nice and isolated. And then I'm going to multiply these two fractions together. When I do that, I multiply top times top and then bottom times bottom. So I get 5/12 as my answer. And so obviously the answer choice was C. For number 9, we're going to subtract 5 from both sides of the equation, isolating the 2x. And we finally get that our answer is 2x is equal to 8, and therefore x is equal to 4. With number 10, we want to isolate y, so we're going to get rid of 7 first by subtracting both sides by 7. We end up with negative 4y is equal to negative 28. We're going to divide both sides by negative 4, and we finally get that our answer is y is equal to a positive 7. In number 11, add 3 to both sides. Then we get m over 6 is equal to positive 11. How do we get rid of that 6 in the denominator? We need to do the opposite of what 6 is doing, which is dividing, so we will multiply. When I multiply both sides, I get that m is equal to 66. With this problem, we need to select what we're going to, quote, get rid of first to isolate D. And I'd like you to think of the division sign letting us know that that's D plus 3 in parentheses. So what we're going to do is get rid of the 5 first, and then we'll go and deal with the parentheses. It's almost like the opposite of the order of operations. It's like you're going backwards. So you'll take care of what's in parentheses last. So in this case, we're going to multiply both sides by 5. To get rid of the 5 in the denominator, we get negative 20 on this side. These 5's cancel out, and we're left with D plus 3. The next thing we need to do is isolate the D, so we're going to subtract or add a negative 3 to both sides. And when I do that, I get a negative 23 is equal to D. Okay, number 13. We're given this information. The average length of a yellow-banded angelfish is 12 inches. This is 4.8 times as long as the common goldfish. We need to write an equation for part A. So I'll do just like what we usually do. The 12 for the length of the angelfish is 4.8 times as long as the length of an average goldfish. So I'm using G for the length of an average goldfish. So that's our equation. And now with that equation, we're going to calculate the average common, the length of an average common goldfish. So really, we're just going to solve. Dividing both sides by 4.8, we're going to get that G is equal to 2.5 inches. In number 14, we're talking about 3 less than something. That's not 3 minus, that is taking 3 away. Because it's 3 less than, you have to take 3 away from an amount. What is the amount? We're taking it away from 3/4 of a number, let's call it x. So when I take 3 away, that is supposed to be equal to negative 9. Solving this, we add 3 to both sides. Then we're left with 3/4 x is equal to 6. Getting rid of that fraction is not a problem. We're going to multiply both sides by the reciprocal of the coefficient of x. So swoop delicious, these guys go away. I should cross cancel. And then I have x is equal to, what I realize is that I did not put a negative 6 here, so I need to do that because remember we came from a negative 9 plus a 3. Sorry about that, guys. So we've got negative 6 over 1 times 4 over 3. I can cross cancel. I get a negative 2 times 5 when I'm done. I'm sorry, 4 when I'm done, and x is equal to negative 8. For number 15, 30 is 12. 30 is 12 added to 6 times a number. So that's 12 plus 6x. And so we need to solve this. Simply subtract 12 on both sides, and then you're left with 6x is equal to 30 minus 12 is going to give us 18. Therefore, x is equal to, I'm going to divide both sides by 6. X is equal to 3. Find four consecutive integers with a sum of 106. When we're talking about four consecutive integers, we're talking about numbers that are coming right after one another. Keep in mind, if they talked about consecutive odd or consecutive even, we would not use x, x plus 1, and x plus 2, and x plus 3 like we're going to do here. What we would use in that case is x, then x plus 2, because and then x plus 4, because we have to jump and skip when we're dealing with even or odd numbers. All right, so let's go ahead and do this problem. So our equation should look like this, and then we're just going to continue like we usually do. Join like terms together and solve. So we get this, then we do a little subtraction on both sides or adding a negative, and we get 4x is equal to 100, and you guys know that x is equal to 25. So if x is equal to 25, x plus 1 is 26, 27, and then x plus 2 is 27, x plus 3 is 28. The next few problems are more involved, so I'm going to try to get a little bit more space. So for 17, 18, 19, we've got to solve and then check our answer. So we're going to make sure we do that by following our rules. We've got variables on both sides. So let's take a look. In number 17, I need to determine what side I want my p terms on and what side I want my constants on. I'm going to put my p's over here and my constants over here. And now I'm going to just move accordingly. On this left side, this 3 doesn't belong, so I'm going to add its opposite and get rid of that. So I'm left with 8p is equal to 5p 9 plus a negative 3, that is supposed to be a 9, plus a negative 3 is going to give me a positive 6. The next thing I need only constants on this side, on the right side, so I'm going to get rid of 5p by adding its additive inverse, which is negative 5p. Finally, I'm left with 3p is equal to a positive 6. Therefore, p is equal to 2. To check this, I rewrite my equation by substituting in 2 and hope for the best. I want things to work out. So 5 times 2 plus 9. So I get 16 plus 3 is equal to 10 plus 9. And therefore 16 plus 3 is, 16 plus 3 is 19. I can add. And 19 is equal to 19. Woohoo, it's right. With number 18, we could do something really slick like multiply the entire equation by 4 to kind of gobble up the denominator, but we're not going to do that because we didn't really talk about that in class a whole lot. We'll talk about that technique a little bit later, but if you feel comfortable, go ahead and try it. If not, let's go ahead and rock it out this way. We know that we need to choose a side for our variables, so I think W should be on this side over here. Our W terms and our constant on this terms, split it in half. Let's get started by adding a negative 6 to both sides. So I'm left with 3/4 W is equal to positive 3 minus 1/4 W. And now I need to move this 1/4 W, so I'm going to add its additive inverse, which is a positive 1/4. And I'm left with 3/4 plus 1/4 is pretty easy to do. That's equal to W. 3/4 W plus 1/4 W is equal to W, and therefore W is equal to 3 because these guys are gone. All right, our check would look like this. We substitute the answer right back into the equation, and therefore we get this next step. Now we need to join our terms together, so we need common denominators if we're going to add. So I gave everything a denominator of 4, and you can see both sides give me 33/4. So I'm feeling good. W does equal 3.